This is another video on graphing parabolas, or quadratic equations. So we started before with y equals x squared, and you can see those are the 3 points that we would get for our basic graph. So if you plug in 0 into x squared, we get 0. You plug in 1, you get 1. And then we have that axis of symmetry there, right at x equals 0. So we get that same point over here, because if you take a negative 1 and square it, you also get the positive 1. So now if we modify these numbers that are around the x squared, so if we take something inside of those parentheses and we subtract or add them, we multiply something outside, or we add something outside, what it does is actually modify our graph. So let's just take a look at A and see what happens. So we have our sliders here, and the link for this is in our module. So if you take A now and you change it, you can see what it does is it vertically stretches it. What we're doing here is taking every single number that we started with before, like the 1, 1, and we're taking that y coordinate now and we're multiplying it by some number in front of A. So it's now 1, 1. So now if I change it to, say, 3.6, let's go even higher. It's all blocked now. Let's go way up there. So if it's 8.5, you can see all we did was take 1 and multiply it by 8.5. So that gives us our next point. So you can see we're at 0, 0. And then our next point will be up 8.5 and over 1. It's kind of like a slope, but it's not. But there is that little rate of change going on right there just for that 1 point. Only works for that 1 point, though, because after that, 2 becomes 4, 3 would become 9, and then we're going to multiply those numbers by 8.5. But you can see it vertically stretches it. And then now if we go negative, you can see it just goes down in the negative direction. So it's negative 2.3. See? So instead of 1, 1, we're now at 1, negative 2.3. So that 1, 1 that's right there is now becoming 1, negative 2.3 if we put a negative 2.3 in front of our x squared. So that's all that number does. It just tells us where we're going to be at. And it works the same way down here. You can see if I go into fraction territory, right? So like negative 0.4 or even a half, negative 0.5, you can see we're down negative 0.5 over 1. So it's a quick way to graph it. We're starting at 0, 0 right there. And then whatever number's in front, you're going to go down that amount and over. And if it's positive, you're going to go up that amount and over. So if it's 2.3, we go up 2.3 over 1. Let's take it back to 1 now so we can see that. All right. Now the h, that is the number that's being subtracted from our graph here, from our x. It's inside the parentheses. And see, let's see what happens. So if I make my h positive, you can see it's x minus 3. We're actually going in that positive direction. So a positive h is what we have in here. You always want to think minus. And the way I remember it is what number would I have to use to take this back to 0? Because that's where we were, right there at 0, 0. So you can see if I take 3, take away 3 would put me right back at our first point, which is 0. That's what we're looking for. So 0 plugged into x squared would give me 0. So 3 plugged into x minus 3 squared would also give me 0. So it's the opposite of whatever number we have here. So you can see, look, if I make it a 4, we're at 4. So going the other way, see how it's now opposite of it. So we're at negative 7. So this would be plus 7. So if you have a plus 7, you're really at negative 7. And if we have a positive 7 right here, then that means we have a minus 7 inside. So there we go. So that's what happens with that h. Now the k is the number being added up. These are the only 3 numbers that we use to modify our graphs. So watch what happens with the k. The k directly moves it up. So if we have a 3, we put a 3. And it's common sense here because right now we're at 0, 0. Our main graph is at 0, 0. And what are we doing with 0? We're adding 3. So 0 plus 3 would be 3. So that means we're adding 3 to every single point. So our 1, 1 is now at 1, 4. And our negative 1, 1 is now at negative 1, 4. So you see all the points just add 4. So by putting a plus k at the end, it literally moves it up. But how we can use it is that is the y coordinate for the vertex. So you can see my vertex is at 0, 2. So if I move my h now over, you can see my vertex here is at 3, 2. And what do we have for our equation? 3 and 2. So it's a quick way to graph it. You take whatever number you have here, and that's how far you go up and over. So our a is up 1 over 1. So if I change my a to 2, Let's just do 2.1. It won't stick at 2. You can see my vertex is at 3, 2. Right there. 3, 2. And then it's up 2.1 over 1, and I put a point and a point. Now, do not keep doing that, because what we're going to get is an absolute value graph, not a parabola. Our parabola is going to go off a lot quicker. So that's all you want to think. X coordinate, Y coordinate, opposite here for the X. So if it's minus 3, put a positive 3, plus 2, and then up 2.1 over 1. So watch, you can just do that for all of them. So if I move my H over here, now we're at a positive 6. So it's negative 6, comma 2, up 2.1. If I wanted to go up even higher, right? So now it's up 5 over 1. So you can see we're at negative 6 and then 2. And then we've gone over 1 from negative 6 to negative 5. So that's our 1 point away. And then our 2 went up 5 to get to 7. So we graph it as negative 6, 2, up 5 over 1. Works the same if we have a fraction. So if that had been an a value of, so I can get it to a half. Perfect. There's a half. You can see we're now at 6, 2, right? So negative 6 and 2. And then it's up a half. So we go up 1/2 over 1. So you can see we went from 2 to 2.5, negative 6 to negative 5. All right, so let's try some. All right, so for our a, that means we're going to go up a and over 1 from our vertex. So from here, we're going to go up a over 1. So up a over 1, get another point, and another point on the other side. Our h is our x coordinate for the vertex, and our k is our y coordinate for the vertex. So when we plot these, you immediately write it in that form. So you can see that we have, this is equal to 5, and then it's just x. So if you want, you can put minus 0 because there's nothing there, and then plus 0 because we're not adding anything to it. So we're not subtracting anything from the x or adding. This means that we have a vertex from these 2 points of 0, 0. So we start with that point. And then our a value here is 5. So we're going to go up 5. So count with me. 1, 2, 3, 4, 5, and then over 1. And then that is our parabola. And then we have symmetry, so we go to the other side. And our axis of symmetry is right through the center of our vertex. So if you're going to do an axis of symmetry, it's x equals 0 is our axis of symmetry. Right down, let's do that in green, right down the center there. All right, let's try another one now. So this one would be just plain old x minus 0 squared plus 2. So our vertex would be 0, 2. So we put a dot at 0, 2, right there. So that means we're not going to move any shifting left or right, and we're going to go up 2. Now our a here is just plain old 1, because there's nothing in front. So we go up 1 over 1, up 1 over 1. So up 1 over 1. And then we'll do it in green. We get our graph. If you want more points, well, then you have to plug them in. So you would plug in 2 and then use symmetry on it. Okay. This would be 3, x minus 0. Notice I'm always putting a minus on that one. So my vertex would be 0, negative 3. Put a dot right there. My a is 3, so I'm going to go up 3 over 1 and over 1. So you can see it's up 1, 2, 3 over 1. Always over 1. And then we graph. So see, you can graph these extremely quick. So this one just needs a plus 0. So my vertex would be 2, 0. And my a is 1. So 2, 0. A is 1. So up 1 over 1. And then we connect. So if you don't see anything in front, it's a 1 sitting there. So this is plus 0. So we would have negative 3, 0. Remember, always opposite. And then my a is 2. So again, negative 3, 0. So 1, 2, 3. Put a dot at negative 3, 0. And then up 2 over 1. up 2 over 1 right there. It's always over 1. And then we connect those dots. And so you can label them if you want. It's even pretty nice. It's -3, 0. So you can see this is for the y coordinate. So these two just add. So 0 plus 2 is 2. So we know we're going to get 2 for that y coordinate. And then it's from -3. We're just going to the right one and to the left one. So it'd be -2 and -4. So like this one is 2, 0. And again, we're adding 1 to it. So 1. And then that would be 3. And then this would be 1, 1 as well. All right. What if they put it in front? Well, you can just leave it there, or you can move it to the other side. But no matter what, that is still your y coordinate. So this is 2, 1. And so we would plot that point right there. And my a, there's nothing in front of the x, so it's a 1. So we go up 1 over 1 and draw our graph. So they're not that bad. They're super quick. And so these are the 3 points you're always going to have on your graph. They should always be listed there. That gives us our points. If you have to label them, again, vertex is easy because you already have it. It's 2, 1. And then these points, you can either count them where they are, or you just think about it. That's 3 because it's to the right one. And that's 1 because it's to the left one. And then you add these two together. So 1 plus 1 is 2. It tells you where the next point would be. All right, here's some more. These now have negatives, so just the same idea. I'm just doing a bunch of points. You can fast forward or stop whenever you want. So this one, there's nothing being added or subtracted to the x, so it's 0, 0. We can put a dot there. The a now is -1, so see, that would just be a -1. So that means we're going to go down 1 over 1, down 1 over 1, and we get this. So with this one, it means you're going down 1 over 1. So we get a reflected graph. This actually goes down in the negative direction. So you can even see it now. If it's positive, our graph goes up. If it's negative, our graph goes down. So you can tell which direction it will open. This one opens in the downward direction because it's negative. So you could say downward, downward, downward. Oh, that's positive, upward, downward, and downward. So let's continue. This is 0, 0. Nothing being added, and my a is -1/2. So 0, 0. And so here's where it gets a little tricky. You have a choice. You can either just say, oh, it's a 1/2 over 1 like that, and then you're good to go. Or you could rechange the numbers. I'm going to leave these as 1, 1 so that we have this. It's not the prettiest graph, but you can see we get a wider graph. So this point is 0, 0. This point now would be 1, -1/2. Same rules apply. We're just adding these two. So -1/2. And then over here, it'd be -1, -1/2. So again, 0, take away a half, -1/2. All right. So as you keep going, you start to see that it's, 0, 0, down 3 over 1, down 3 over 1. Nice and quick. No points to plug in. That's the whole point. You want nice, quick graphs. You've got lots of applications. So if you can graph these quickly, you can visually see what your application is based on where it is. So again, that's 0, 0, and that would be 1, -3, and -1, -3. There you go. All right, 3 more, and then I think that's more than enough applications. How many is that? Or examples? That would have been 3, 6, 9, 12. So we just did 12 examples in like 5 minutes. That's how fast these are. All right, so you can see on this one, my x coordinate is 2. This guy right here, we change the sign, and then my y coordinate is sitting right there. So 1. All right, so that's our point that we start with, 2, 1. What's my a? My a is 2. So we're going to go up 2 over 1, up 2 over 1, just like that. So you can see those are the points. We start at 2, 1, our vertex. And so that would be 3, and then 2. Sorry, we'll go in order. 1 plus 2 is 3. And then the other side would be 1, 3. And then there are your points. Solid dot, and then we go up and up. So that's all we're doing on each of these. Let me look at Desmos again real quick. So there's a slightly different way of looking at it. So you can remember that func problem we had is 1 plus 2 x minus 2. So a vertex is at 2, 1. So if we go to 2, I'm just going to put it in 2, 1. You can see that's now our vertex. And then our a value was 2 right here. So we shift it up 2 right there. And there's our graph. So you can see there's our points. We have 2, 1. And then that would be 3, 3 and 1, 3. That gives it to us. And if that a had been a negative 2, it would have just gone down 2. So everything starts at that vertex. And then all we have to do is use the a to tell us where the next 2 points are, because we have symmetry about that x equals a axis. All right. So the next one is a negative 2 and a negative 1. So that would become 1, 0 for our vertex, because we're not adding anything to our function. So our h would be 1. Our k would be 0. So right there's our vertex. Now we just need that a to tell us what we're doing, and it's a negative 2. So my a would be negative 2 right there. That's my graph. So we're starting at 1, 0, 1, 0. See? And there's our graph. Negative 2x squared, x minus 1 plus 0. So 1, 0, put a dot, and then it's down 2 over 1, down 2 over 1. And we graph. So lots of examples. All right, last one. I think we've covered everything now. So again, what's the opposite? Negative 3. And then same. So negative 1. That's our vertex. So negative 3, negative 1. Put our dot. That's our starting point. Negative 3, negative 1. Right there. And then my a is whatever's in front. So that's a negative 1. And it's practice. The more you do these, you've seen every single situation where these occur with more practice. Well, you can't see every situation, but you've seen enough to know each exact type. And so you start to read them very quick, and you'll graph them very quick. So this page right here, after you've practiced a lot, you should be able to do it easily in 5 minutes at most. And there's your graph. And there we go. So you can see it's 1 to the right, and then down 1, or down 1 over 1, however you want. But that was our function. So negative 1, x minus 3, negative 1. Negative 1, x plus 3, negative 1. All right. Oh, it's a minus, minus. It's a plus there. Can't see it, but it's a plus right on the line right there. So that's a plus. Here. It hides it even more. Its location doesn't work well because of where it's at. You can see, but it is pluses there. It's one of those little spoofs. All right, well, hopefully that works for you. Thank you for watching.